Okay, hello there. This video is going to be about, it's going to be an interesting one about making the radius the subject for the lateral area of a cone. Okay, and just going to begin by talking about the lateral area of a cone real quick. All right, so the lateral area of a cone is the curved area of the cone. Not, well, the circle's curved, but all the area of a cone except for the circle bit. All right, so to just investigate this real quick, if we look at the height of a cone and its radius and its slant height, well, obviously these are connected by Pythagoras, and we can say, what can we say? We can say that h squared plus r squared equals the slant height squared because of Pythagoras. And if we rearrange all this, we're going to get that the slant height is the square root of h squared plus r squared. Okay, so that expression can be put in for right there. So the formula for the lateral area, this part of the cone, is nothing major if we use the slant height. It's just pi times radius times L. Okay, and that's no biggie. But if we replace L for this expression here, it becomes a completely different formula. So if we say pi times radius times the square root of h squared plus r squared, now it becomes completely different. So what I'm going to do in this video is I'm going to make the radius, I'm going to make r the subject in this equation right here. And first of all, this idea was posed to me by a question on one of my videos on my YouTube channel. And I was having a conversation back and forth with this person, and I said, there's no way I can explain this in the comment section, so here I am, making a video of it. So let's begin. Making r the subject means getting this guy by itself. All right? So stick with me on this, and it's going to be a wild ride. So here's what I did. I didn't know where I was going with this problem, so I just thought, well, what can I do? The first thing I did was I changed the square root thing here to an exponent of 1/2. Okay. After that, what I did was I squared both sides, which will get rid of the 1/2 exponent. No, scratch that. I'm going to divide both sides, sorry about that, by pi over r. Okay, that way these guys cancel out first. So I'm not doing any exponent yet. And I rewrite the equation, and I say, all right, now I'm going to square both sides to get rid of that 1/2 exponent. So I'm going to square both sides, and I get that pretty little picture. All right, now what's next here? So okay, I'm walking down a road I'm not really too sure of just now. So I simplified this guy over here. So I squared both of these, and I get that. Okay, I don't really need the brackets over here right now, but that's okay. And now what I did was I multiplied both sides by this pi squared r squared. So I got this guy over to that side. Okay, if you're following me, and I get a squared equals pi squared r squared times h squared plus r squared. Okay, well that's, I don't know, that's a little bit better. And now what I'm going to do is, what did I do here? I think I expanded. Yeah, I expanded this through. That's what I did. I expanded that through. And I get, when I multiplied this through, I get pi squared h squared r squared. And then when I expand it to this term, I get pi squared times r to the 4th. Yeah. All right, now here's where the equation took an unexpected turn because I didn't really know what to do here. And I thought, can I start to treat this like a quadratic? And you're thinking, well, it can't be a quadratic if I'm solving for r because a quadratic means squared's got to be the highest power. And I've got r to the 4th. Okay, so I wasn't sure. So I set it equal to 0 anyway. So I'm going to subtract that a squared from both sides and set this equation equal to 0. And that's what I get. So I subtracted that to the other side. I set it equal to 0, and I just swap sides of the equation, so I got my r on the left. Okay, now here what I'm going to do, and I'll show you why, I'm just going to swap these two terms here. Okay, so these two terms, I'm just going to swap them because I want to try to make it look like a quadratic. So I'm going to say, okay, so I got that. Now what I'm going to do, I said, hey, I can try to kind of work turning it into a quadratic if I let x equal r squared. So if I let x equals r squared, sorry about that, then I can rewrite this equation, and it will look like a quadratic, sort of. I mean, the pi is a funny coefficient, but we can deal with that. Now, just watch what I do here. So if x equals r squared, that means r to the fourth is going to be x squared. So I got pi squared x squared, because if I square r squared, I get r to the fourth, plus, pi squared h squared. Well, r squared is just going to be x minus a squared equals 0. All right, so now what I have is I have a quadratic. There's my x squared term, there's my x term, and there's my constant term. So I'm going to say, and I can use a quadratic formula here to get x by itself. And if I get x by itself, if x equals r squared, then r is going to equal the square root of x. Right? Well, let's just see here. If I use my quadratic formula, and this is going to be a, this is going to be b, and this is going to be c. Okay, so these will be my a, b, and c for quadratic formula. And then once I get x, I'm just going to square root that answer to get the radius. Okay, so what's my quadratic formula? Okay, so I'm going to do the very daunting task of substituting these guys into this. And it's not pretty, but let's just kind of work carefully, and we'll put them in there. Okay, I knew this would happen on this problem, kind of running out of space. All right, well let's just do it. Okay, we got x equals the opposite of b, so x equals negative pi squared h squared plus or minus. And I'm going to tell you what I'm going to do with this later, with this plus or minus thing. B squared, b is pi squared h squared squared minus 4 times a, which is pi squared, times c, which is negative a squared. Let's make that square root symbol a little bit longer, all over 2 times a, which is pi squared. Okay, whew, now I'm getting there. I can do a little bit of simplifying inside the square root symbol, and I'm just going to rewrite this. Inside here, I'm going to pi squared squareds pi to the fourth. H squared squared is h to the fourth. All of this simplified is positive 4a squared pi squared, I think. Is that right? Yeah. Positive 4, I'll put the pi squared first. Pi squared a squared all over 2 pi squared. 2 pi squared. Okay, I can't, now I looked at, okay, this is a lot. I looked at this right here, and I thought, well, I could factorize a pi squared out, and I could do some simplifying in here. I can't collect any like terms, but I just left it. I thought, you know what, it can stay there. It's not going to be a major thing. Well, we're almost there, because if this is x, the radius is going to be the square root of all this. The radius is just going to be the square root of all this. Now, radius equals the square root of all of this. However, I can't keep this a minus because I will get a negative for this top value. Now, that's a whole other set of working, which, trust me, just take my word for it, we can't have a minus right there. So finally, the radius is going to be the square root of all this, which is Okay, what a problem that is. Now, again, it's hard to imagine that something so simple. So here's my original formula. Making R the subject is going to turn out to get something as complicated as that. Just from finding the radius of the cone given the lateral area. That's it. I've checked it. There's other variations of this. So like I said, you can factorize, you can simplify a little bit more in here, but you could make the radicals different exponents. You can make them one, or the square roots 1/2 exponents if you want to. But that's how we do it. That's the whole entire problem, which is a big one. Okay, if you've managed to make it through this long of a video about this, thank you very much. Okay, well done. See you later. Thanks for watching. Bye bye.